Hello everyone, today I will talk about our research, rapid domain platform performance prediction for design space exploration. As we know, streaming processing has been applied in many fields, for example, the virtual reality and auto driving. Streaming processing always has the real-time requirement because it needs to interact with the environment. This processing always is executed at the edge to avoid large volume data transfer to reduce latency, which means that streaming processing needs to run the server class algorithm at the edge. And here is the challenge. The streaming processing needs to achieve the high performance computing with the area cost and the power constraint. It also needs to keep some flexibilities. And the current approach to execute the stream processing at the edge is to design the application-specific heterogeneous platform which combines hardware and software. The hardware part is application-specific accelerator to accelerate the processing-intensive computing, which can achieve the high-performance computing and fit for the area and cost constraint. And the software part is just the general-purpose processor to keep some flexibility. However, there is a problem in application-specific platform. It is only efficient for its own application and is inefficient for other applications because the application-specific accelerator is overfitted when the other application running on the application-specific platform, most execution is executed on the software. And what's worse is that designing one platform for each application is not manageable. It will have tremendous design cost, which is a non-recurring engineering cost. It is also hard to maintain this. The solution for that is that we can design the domain-specific platform, which is the one unified platform for many applications with some similarities. In the domain platform, we can deploy the same accelerator to accelerate the common processing patterns in many applications, which can retain the most performance as well as to keep the low cost. The domain concept here is the set of applications with functional and structural similarities. For example, the applications built on top of the same library, we can consider them as the same domain. In our previous approach, we introduced the domain design space exploration, domain DSE, to obtain the domain platform according to the domain applications. And in the experiment result, the OpenVX domain with 40 applications, our domain platform can achieve more than 10 times performance better than the application-specific platform. And using one domain platform can achieve 80% efficiency compared with the 40 different dedicated application-specific platforms. However, there are some challenges in domain DSE. As we know, the traditional application DSE is already really hard considering complex application platform allocation and application binding. As we know, the application DSE is only designed one platform for one individual applications. However, in the domain DSE, we need to design one platform for multiple applications, which means that they need to consider more accelerator candidates in the platform allocation, and it need to do the multiple application binding for each allocation. And this complexity makes the domain DSE suffer from a long exploration time. Even for a small OpenVX domain, the exploration time becomes unacceptable when the area budget becomes large. So we do need to speed up the domain DSE. To speed up domain DSE, let's first look at the domain DSE flow and figure out this bottleneck. The domain DSE first need to do the platform allocation exploration to select the accelerator to allocate on the hardware tail. And then for each platform allocation, it need to bite the application onto it to explore how the application function binding on the software part or the hardware part. After obtaining a specific binding, it need to evaluate the application performance on this platform. And at the last step, it need to aggregate multiple application performance to obtain the platform performance in domain level. Now here is the problem. For one platform allocation, it need to explore and evaluate multiple bindings and for multiple applications to obtain the platform performance. There are too many evaluation need to run to obtain one platform performance, which is the bottleneck in the domain DSC. To solve this bottleneck, we introduce rapid domain platform performance prediction, RDP-Cube, to predict platform performance in domain level developed based on the accelerator locations. After we using the RDP-Cube, we can avoid the complex application binding exploration, the application performance evaluation, and the multiple application performance aggregation, which can tremendously save a lot of time. And we use the multi-layer perception MLP to predict the domain platform performance. The input feature is the couple bytes to represent the accelerator allocation for the platform, and the output is the platform performance. And between them, there are a couple hidden layers with training with 1,000 random platform allocation and their performance. We also run some other prediction model, for example, linear regression, decision tree, and other heuristic predictions. Here is the RDP-Cube performance for the OpenVX. From the figure, we can find out the multi-layer perception has the lowest error, and its training and the prediction time is acceptable, which is also fast compared with the domain DSC exploration time. And after we apply the MLP into domain DSE, they can save the 80% of the exploration time, and with the area budget increase, we found out the domain DSE exploration time become acceptable. Here's the conclusion. Domain DSE is needed to recovering the non-recurring engineering cost, and we declare that the domain DSE is suffering from long exploration time, and then we introduced that the rapid domain DSE performance prediction to speed up the domain DSE. After apply this prediction, the domain DSE can save 80% of exploration time. That's all. Thank you. Any question?